So the key concepts here that a quadrilateral is any four-sided figure where the angles inside are less than 180. It can be greater than 90, but less than 180. The one thing we do know is that the diagonals of a quadrilateral will bisect each other. So from here to here, just draw it across here, that diagonal will intersect that diagonal, sorry about on straight lines. If the quadrilateral is a parallelogram, then we know that the two sides will bisect each other, two diagonals will bisect each other. The other thing we know about quadrilateral, gone thick ink here, thick pen here, I'm not sure why I've gone thick pen, but I will. We know that if we take the midpoints of each of the sides, let's do a different color here, so there's the midpoint there, and the midpoint there, and the midpoint here, and the midpoint. So we take those four midpoints and join them up, then the shape that is formed will always be a parallelogram. And a parallelogram has opposite sides equal and opposite sides obviously parallel with each other as well. And the arrows mean parallel and the dashes mean sides are congruent. So any quadrilateral, when the midpoints are joined up, forms a parallelogram. Any quadrilateral will have the diagonals bisect each other. So question 1 from the homework says, which of the line segments inside each parallelogram are equal in length? That's what that question says there. And it's a parallelogram because the opposite lines are parallel. So we know that a parallelogram, the diagonals will bisect each other. So we know that that equals that, AE equals EC, and of course ED equals EB. So this is what you'd write down for question A, is that AE, so A would be AE equals EC, and the other one is that BE equals segment ED. And of course if you did B, you'd have a similar situation. You have to sort that out. And that was question 1. Question 2 over here, 2A we'll look at first. We know that G, H, E, and F are midpoints because we've got these digits, these segments either side equal. So therefore, this quadrilateral EHGF must be a parallelogram. That side must be parallel to that side. So HG is parallel to EF, and that's the parallel sign. And of course we know that this one here, FG, must be parallel to EH, and FG must be parallel to EH. And then you can do the same for B, work out the parallel sides. So what we do know, when we got a trapezium like this, we know that it's a trapezium because two sides are parallel. So I know that this is parallel to this. When we have the segment that cuts each side in half, so those two are equal to those two, etc., etc., this third line is also parallel. But we also know that the third line, if this length is A and this length is B, then C will be the midpoint, the median, so that C equals A plus B over 2. So for instance, if A was equal to 10 and B was equal to 16, then C would be 10 plus 16, which is 26, divided by 2 would be 13. And it follows a little progression here, plus 3 and then plus 3, 10, 13, 16. So question 4 says, which line segments are parallel in the figure below? We already know that AD is parallel to BC. Find the length of EG. So you know that AB equals equals 16. And you know that BC equals 4. 2 plus 2 and 8 plus 8. So therefore, this is question 4, part B. You know that EG will equal AD plus BC, and then divide by 2. And we know both of those values. We've got 16 plus 4 divided by 2 is 20 divided by 2, which is equal to 10. So EG is 10. And the last bit says find the length of FH, and FH is going to be this distance down the bottom here. Question 8 is a bit different. Draw two line segments AC and BD that bisect each other at a right angle. So I'll try and do my best here. There's one and there's the other. So AC and BD, and we know that the angle in between them is a right angle. Then draw a quadrilateral that has AC and BD as its diagonal. So therefore we're going to join up the outside points like this. There's the quadrilateral there. Like that. Classify the quadrilateral, justify this sum. So what we've got is triangles here that cut at right angles, and we have ABCD is going to be a rhombus. Because the lines bisect each other, we know that that equals that and that equals that, and because all four of these angles are right angles, we produce four congruent triangles. The triangles are exactly the same, congruent, and if they're exactly the same, therefore on the outside we know that that must equal that, must equal that, and must equal that. Therefore we have a rhombus, and the diagonals of a rhombus bisect each other at right angles. Part B here, and maybe you could do this on your own. Find the midpoints of A, B, C, D, and labeling these points and respectively draw line segments, join the midpoints, classify the quadrilateral E, F, G, H.